This is bad. I was totally not paying attention and I stopped the video. Oh, I don't know why I paused it, but I just forgot to bring it back. So this is how far. This is how far we've gone. I saw that the filter capacitor to the bridge rectifier already, the plus and minus. That's it. I used the red for the open color for the plus and brown for minus. Yeah. So now I'm about to test. Let me plug it on power. So this is what will happen here. Hey, let me be careful. I don't know if the heating is conducting material. Let me check. Put my meter in continuity. From here to here. No. It's not conducting material. Or you have to scrub it before you can conduct. Let me see. Maybe that's just paint coating. Oh yeah. It's actually conducting material. But you will have to scrape that off before you can conduct because there is paint there. So we don't have to bother much about placing this on it. So let me plug it in and let's see what we have on the capacitor, the filter capacitor. Nothing blew up. Good. So what will happen? What we're going to get from the capacitor is like double what we have on the bridge rectifier. You see why? You say why? Why? That's it. 41 volts on the filter capacitor. 41 volts, yeah. But on the bridge rectifier, we have like 27, right? Yeah. So it's close to double the original voltage from the bridge rectifier. So now we have a power supply. If you want a constant power supply of 40 volts, you can use this one. Right? No. Okay. If you are connecting a load on this one, actually the voltage will drop, and what we have, what is actually usable at the end, is the voltage that we have on the bridge rectifier without the capacitor. Am I making sense? Okay. Okay. This is good. So this is okay, the capacitor. And let's move to the next part. So already we have a transformer, the bridge rectifier, and the filter capacitor. Right? But I feel like I want to use two filter capacitors. That's okay. It's okay. We don't have a problem if we use two filter capacitors. It's just for more safety, you know. But this one is okay actually. It's okay. So the bench power supply is the kind of power supply that you'll be able to vary the voltage, be able to adjust the voltage from maybe a low value to a high value depending on what you want. And what we're going to use for this is the variable resistor. This one, yeah, it's a variable resistor of 50,000 ohms, 50k. So this is a 50k variable resistor. I got this one from the subwoofer systems. So here is a transistor. This is the first transistor. This is the only way we can do that. Vary from a low value to a high value. We're going to use the variable resistor with the transistor, the NPN in our case. So how the transistor is working? First, we have the output that is here. Pen. Okay, I got the pen. So this is the transistor, the NPN transistor. And if you are using this one, this is how it's working. It's working. Remember, it's working as a switch and as an amplifier. That's why we can have a small voltage at the base, because this is the structure. You have a base, collector, and emitter for the NPN. This one actually. So we can have a small voltage at the base, and we can play with high voltages at the collector and emitter. So for the transistor to be able to get open, we need to have our base and emitter to be compared at 0.6 volts. So we have a 0.6 volts here. The transistor is going to open, and when the transistor opens, voltage is moving from the collector to the emitter. At this point, we have our output that is here. Wait. So at this point, we have the emitter here, which is here on the schematic. So we need to have voltage at the collector. That's going to move from the collector to the emitter in the case where it's open. So let's do it. Alright, forget about this other one. Okay, this one, we're going to come to this. So let's use a transistor. Let's get one. So the transistors are going to stay on the heatsink, and the variable resistor. So we will play with the variable resistor here at the base of the transistor. So if you are increasing the resistance, it depends if you are reducing or increasing the resistance, the voltage should either increase or reduce. Same thing goes for the collector and not the collector, is not changing. What is getting changed is the emitter. So we can have 0.6 volts here and maybe something at the emitter. Good. So let's do it. It's easy. It's easily done and said. It's easily done. It's easy to see how it's working by doing it rather than talking about it. So this is the collector, remember, the middle pin. The middle pin is the collector, and the collector is coming to the output. Okay, I knew it. I knew I was going to come to this. I need long wires. Okay, maybe not forever, because we'll find a comfortable spot. So it's coming to the collector. What is going on here? I need a long wire. Ugh. So I'll still get more wires from my transformer. I don't want to be greedy with the wires. don't think I'm going to use this transformer for something else but this power supply. Okay. Yeah. So we'll run this wire from the collector of the transistor to the plus pin of the capacitor. So this transistor is C3002, but you can use anything that you have. You can use what you have. I'm using this because it has high power. There was something above 90 watts, I guess. 90 watts. Can't remember. But like 270 volts DC. So that's why. Okay. From here, I'm using brown as plus. This is crazy. Nobody can troubleshoot this board but me. From here, I'm using brown as plus here. So it's coming from the collector to here, the plus of the capacitor. I feel that this iron is shaking. Can't believe. Okay, let me solder that to the capacitor. Good. So I solder that to the capacitor, the plus, and then let's check on the schematic. On the base and we have ground. So now we can actually connect a load, right? We have ground on the capacitor here, the capacitor there. So now we have ground on the capacitor. Remember, this voltage is coming from the capacitor here, which is we have the 40 volts from the capacitor. So we have plus and minus, plus here, and this is coming to the collector. So now we can actually put a load across now, yeah, a load which is a voltmeter or a light bulb, right? Can be a voltmeter or a light bulb. We can put that across the emitter. So let's put something on the emitter. Let's forget about the base for now. The base, we'll play with the base. We are going to play with the base with the variable resistor. Let's put something on the emitter. A light bulb. Set the light bulb. Okay. You know what? I don't know what to hook on the emitter. I didn't think of this. I have a light bulb here, but it's way too small. This is just a 12-volt light bulb. If I connect this across, then it's dead. I'm going to kill it unless I have to, because I'm not even sure of the current of the transistor of the transformer. Sorry. Let me get a light bulb. I have a light bulb somewhere. Okay, I got a light bulb. I knew I had a light bulb somewhere here. So I put some wires across it already. I didn't forget to switch the camera again. It's always when I'm looking for things that I'm stopping the camera and stopping and stopping. Okay. So I have a light bulb. Ask me why I'm using a light bulb. The light bulb does not have a plus. Okay, it's shaking inside. I don't know if it's still good. Remember, in the olden days, when this thing is not working or if it's bad, you hear some filaments shaking inside. They're always very small. But sometimes they still work though. So this one is the 230 volts light bulb, but it doesn't have plus or minus, so you can think about it as a resistance. It doesn't matter if you put it on plus or minus. We're testing DC. So you'll be wondering if you can work on DC. Yes, you can work on DC, but in this case, it's not going to be very bright because you have just 40 volts here, but you should see something, or you should get a little hot. Yeah, you should get a little hot. So we're putting this on the emitter. So this is a load. On the output and on ground. Should we solder that, or let me just place it on ground? You can use the ground of the bridge rectifier. It's okay. Okay, so let me plug this in. Remember, on the capacitor we have 30 volts. Is that it? No, not 30, 40 on the capacitor. So let's check. I'm a multimeter here. DC. So we're taking ground from here, ground to collector. Remember, the DC is coming from the capacitor. So on the collector we have what? Can't believe. Okay, 41.5 volts. So that's what we have on the collector. Is okay. So the load connected to ground. Yeah, ground. That's okay. But it didn't light up. Ask me why it didn't light up. Yes, it cannot light up because it's connected on the emitter of the transistor. Remember, and for the transistor to be open, you also have 0.6 volts at the base, or right, you need to have 0.6 volts at the base at least. So that is why the transistor is a switch. Okay, I had a tweezer on this bench. What's happening to me? What's happening? Wait, give me a second. I'm going to pause the video because I'll need a tweezer. You know, the voltage on the collector has to move to the emitter. Remember, the voltage on the collector here has got to move to the emitter for the transistor to be on, right? So that means that if you short the collector and the emitter, the light bulb should turn on, right? So we're putting 40 volts on the emitter. So let me get tweezer in a second. I'll switch off the iron. I'm going to just wait for it to heat up a little. So I'm going to use this wire to short the base and the collector. So we have voltage So if you have voltage at the base and the collector, if you short this and this, you should have the transistor should be open, and we'll have a voltage from the collector to the emitter here. So what we're putting here is more than 0.6 volts. The base collector base voltage is 40 volts. We're going to short that and see what we have at the collector. Alright, I guess the iron is hot now. I don't know I have to use such a long wire. Well, maybe because so I'm going to short the base and the collector. They are so close, I didn't notice. I didn't even check. I was just concentrating on finding the tweezer, you know. Okay, so this thing is still connected. That's very dangerous. Disconnect. And you know, we are still going to have voltage at the capacitor, you know, because as it's on, the capacitor is getting charged. Let me see if you have something here. I just disconnected. Huh? Did I even disconnect at all? Yeah, it's disconnected. But we have 41 volts. Okay, this is where we have trouble. We have problems here. Remember I asked from the start if we had any problem connecting two capacitors in a parallel mode, just for safety. You can imagine this one is was it 200 volts? Yeah, 200 volts, 470 microfarads. It's a very high capacity, way more than the 41 volts that we have here. We should have had like a 100 volts capacitor here. Alright, but I'm putting a 200 volts because that's what I have. So it's storing up a lot of charge for a very long time. It's storing the charge for a very long time. So imagine we had two capacitors there. It was really going to be a battery. You see that it's not even going down. It's stuck on 40. So it's well charged and it's going down just bit, you see, on 40. So if we had two of these here, we could actually use it as a power reserve, you know that, like a battery. So it's still charged and it's not good to solder in this way. So I have to somehow discharge it. And how am I going to do that? Let me connect a load on it. I don't want to short the two terminals like it's always done. I want to connect a load. I don't know if this is ground. No, this is not connected to ground. No. But if I desolder the load, yeah, let me desolder the load and then connect across the capacitor. That's going to discharge the capacitor. Right? Yeah, capacitor should be discharged now. Let's check again. See, we have 0.2 volts, so it's completely discharged. Alright, that was insane. Keeping voltage for that long. We could still short it down, but I just want to be careful. So this one was on the output. Trust me, the lighting here is not good. I cannot see anything. See. So let me plug that. Remember? Oh no, not yet, not yet. I'm getting confused. Okay, this one is going to ground. That's the load. So I short in the base and the collector. Base, and we have this one on the collector. Yeah. So I shorted the base and the collector, and this one will go to ground. Let's plug that on power. Alright, this thing is not seeing anything. Ah. Okay, I just plugged that in. The base is shorted to the connector, and let's connect this to minus. You see, it lights up the bulb. The bulb is lighting up. Amazing. It's lighting up. Wait, yeah, we can still see that. We can see that clearly. You see, it's not very bright because it's just 40 volts, you know. Yeah, this is not getting hot because it's not taking so much power at 40 volts. Let me turn on the lights. Yeah, you see, it's on. The light bulb. So this is to confirm that our transistor is okay and it's an NPN. And at this point, if we check the voltage on the base to emitter, we have 0.6 indeed. Let me see. Here are disconnecting. Right. And how am I going to do this? Let me sort that out a bit. I'll sort out this on the minus. So this is stagely on, and I'll show you what I mean. You know, I said the transistor has to be open at 0.6 volts. So now it's open. So we should measure 0.6 volts at the base to emitter. Let's check it together and see. Alright, let's check the base to emitter. This is the base and this is the emitter. Indeed, we have 0.6 volts. You see? That's it. Amazing. Okay, so I'll disconnect this. We have the load, and let's check on the capacitor. I told you when we connect the load on the output, the voltage on the capacitor is going to drop. And from here to here on the capacitor, what we have 39 volts. 39 volts. Yeah, that was like 40, but now it's 39. Let's disconnect the load and see. 39.6. 39.6. Okay, let me disconnect the load.